industry session where there'll be sort of a heated debate. At least we're hoping there'll be a heated debate. So today, we're going to hear 4 talks right now. The first one is going to be about the basics, experimentation, right? If you can't A/B test, then we're done. After that, there'll be 2 talks from Facebook. One of them will be on how do we recommend to Facebook users the right Facebook pages to look at. The other one will be, if you think of your newsfeed as your own personalized newspaper, how do you generate over 1 billion personalized newspapers?
We actually have seen as we try to scale our experimentation. So the concept of A/B testing at a very high level is simple. I have a yellow button on the page that I don't think it's getting enough clicks. So how about a green button instead? To do it in the A/B testing way, I'm going to start to randomly sample users to see the green button. And then at the end of the day, I will compare and I will collect data from both buckets of users and actually compare them side by side to decide which one is actually better. The old version, the yellow button, is my control. And the new version, the green button, is my treatment. So it may be surprising, but it turns out that one of the biggest challenges is actually really decide what we should be A/B testing on. Let me start with a story. So on LinkedIn, for each of our members, we have a profile page. So on top of the profile page, we actually have a line of text, and that is our top ads. So whenever somebody clicks on these ads, we make. It turns out that it was because during a bug fix, 5 pixels were accidentally removed between the navigation bar and the top ads. And that 5 pixels not only cost us a lot of resources to investigate, but also LinkedIn a lot of money because we were losing clicks on these ads for quite a few days. So when it comes to think about what we should be A/B testing on, people are very used to the idea of let's use A/B tests to evaluate new ideas. I have a new UI change, I have a new recommender system. But how about platform changes? How about code refactoring? How about bug fixes? I was always told, I am usually told, that this new components for the platform is just so much better. It's more efficient, it uses less memory, it's written in better code. And it also has satisfied all the exit criteria. We are ready to launch. But in a truly data-driven culture, the final exit criteria should always be an A/B test. Infrastructure details to a couple of references at the end of the talk. So over the past year, we really have increased the number of experiments that have run through our system by quite a lot. So today, on a daily basis, we run over 200 experiments in parallel. And for each experiment, we actually process over 800 metrics and also billions of experiment events. So it turns out that most of these challenges that we have seen as we scale our experiments differently. So the way that we address this challenge is by building a centralized experimentation platform that we call XLNT. It's self-served, meaning that we can easily onboard an experiment to the system with little to no cost. At the same time, it's also customized to fit the needs of various different teams. This is essentially like we make a pizza, but the teams actually get to put on their own toppings. So what I'm going to do next is I'm actually going to go through how we achieve that in the 3 components of our A/B system. First of all, during the experimental design phase, the experiment management system actually allows teams to do a fully customized targeting. To be more concrete, for example, if I think that I actually wanted to try a larger profile picture on the profiles that are shorter with only 1 or 2 positions, I can do that easily by selecting one of the 40+ built-in targets, only a small subset of the total user population. But not every single member of this target population is actually going to see my experiment, right? Only those who actually had at least one profile view was going to be affected. And that is my triggered population. So our infrastructure actually allows us to identify this triggered population by logging when a request is actually affected by the experiment. It also does counterfactual logging. So there's no point of running an experiment unless you actually analyze it. So we also build an automated analytics system. As I mentioned earlier, we have over 800 metrics that we compute for each experiment. That's a lot of metrics. So how do we manage that? The way that we do that is actually by having a decentralized ownership, meaning different teams, different product teams, actually own the logic of the metrics. But the central platform provides an easy way for them to onboard these metrics into the system. And the central experimentation team is responsible to make sure that the metrics that they added into the system are valid and also verified. Of course, we also make sure that the generation of this metric actually goes smoothly on a daily basis. As a must, we also provide p-values, confidence intervals, to help teams to actually identify the metrics that are actually moved from the ones that were just noise. We also allow the teams to actually have tools and processes in place to ensure that the teams are actually running the right experiments and also drawing the right conclusions from these experiments. Let me start with another story. So if you have used the search functionality at LinkedIn, which I'm confident that everybody here has done so, you probably have noticed that about a year and a half ago, we have made a big change to our search. Before that, you have to tell the search box whether you are searching for a person, a company. First started to run an experiment. This is what they did. They lumped pretty much every single thing together. Guess what happened? Pretty much every single metric tanked. And in order to figure out what went wrong, the team actually had to put one feature back at a time to be parity with what it was in the pre-unified search. And after a lengthy time period, they finally figured out that this unified search is actually great. It's great for the user, very positive experience. It was some of these minor UI changes that they were doing that was actually degrading the metrics. So we realized that the platform needs to actually allow to run multiple factors independently and multivariate tests if necessary, so that teams, when they run experiments, they can tease out the impact from various different factors and really be able to measure one change at a time. Now with a slight better resolution, I can start to actually identify the bigger differences, right? I can see that one frog is having a belly button, and the lily pads are also facing in different directions. How about now? Now we can even tell the minor differences. I can see that one frog is smoking, and the other frog is having his tongue sticking out. So this is exactly what we're doing when doing A/B testing, right? We try to tell the difference between A and B. And the better the resolution that we have, the better that we can do at detecting the differences. So let me put it in a more A/B testing example. So we all know that site speed matters. As a matter of fact, various different companies in this industry have actually done independent A/B tests to show that whenever you increase the page load time, you actually drop the user engagement. But when AC.com was doing a similar experiment, they degraded their page by 200 milliseconds, and their conclusion is that it did not matter. Is it really because AT.com users are just not sensitive to speed? I don't think so. I think it's because they did not have enough resolution, or in the statistical term, power, to actually identify the difference that 200 milliseconds actually brought. So imagine that we're running more and more experiments, right? And then a lot of them are actually at low resolution. We are really in danger of making a lot of wrong decisions, launching wrong products and missing out on the good ones. So at LinkedIn, by realizing that, we are building tools that can not only tell experiment owners that they did not have enough power to actually to make the decision, but also try to guide them in terms of what the recommended action should be, whether they should be launching it, whether they should be ramping it up to a higher percentage, or they should actually be using be running the experiment for a longer time period. One question that I get asked a lot from our folks, I have this experiment that was running, but this metric pop up as significant and it has nothing to do with my experiment. What went wrong? So if you know about A/B testing, you'll be like, okay, that is pretty normal, right? Because even if I'm showing a screenshot of an AA test, we still see metrics that are significant. So it's because we use a p-value 0.05 as a cutoff, and that allows 5% false positives. Divide them up into 3 different groups, right? The first order metrics are the ones that are directly impacted by the experiment. And the second order are the ones that could be impacted by the experiment. For example, if you are changing the color of the button, then the CTR of that button should actually be in the first order metric. And then instead of using a uniform 0.05 as the p-value cutoff, we tell teams to use something that's more stringent for the second order and the third order metrics. And it turns out that this actually has a very nice bit solving this multiple testing concern that we have with having 800 metrics at the same time. So one other thing that I have to say is that so far, we have mostly been focusing on talking about how we can enable people to run experiment, analyze the experiment. And when they finish running the experiments, we try to give them as many metrics to look at as possible, right? But one thing we didn't realize is that these experiment owners actually also play a slightly different role. They are also owners of the metrics. For example, if I'm on the profile team, on one hand, I'll be running experiments, try to actually optimize the total number of profile views. But at the same time, I actually also am responsible for the global health of the profile views as well, which actually is going to be impacted not just by my experiment, but also several other experiments that are running as well. So in order to provide that visibility to the metrics owners, and also make sure that the experiment owners actually, when they ramp up, they actually ramp up responsibly. What we do is we provide a tool where people can go in and then select a metric, and it gives you the top experiments that actually are impacting that metric. It turns out to be not so easy of a task, right? As I mentioned earlier, we have over 200 experiments running in parallel. So we need to first definitely control the false discovery rate. This is also a multi-objective ranking problem, because we not only should consider the impact of the experiment, but also the noise level, the duration, for example. We don't want it to be examining this experiment when it's actually having a novelty effect. How about seasonalities as well, right? So there's a lot of factors that we don't look at them automatically at this point, because the teams can actually run their experiments disjointly if they wanted to. So we don't do that proactively by checking all the pairwise interactions. And also from sort of a lot of studies that other kind of the research community have done, that the interaction usually happens very unlikely. But it's definitely something that we have it on our roadmap to actually be able to see, do we need to do this on a more...
Thanks for coming to this talk. My name is Jin Yi.